So if this look okay to you, f of x equals log base 10 x cubed
Mhm.
plus 1. All right, so we're using the following here: ddx log base b of x. The derivative of this is always 1 over x, and then the natural log of b is always in the denominator. This one
Okay.
has a chain rule part of it. So sometimes I show this as like, it's really du log base b of u, 1 over u natural log of b times u prime. That's that chain rule part of it.
Okay.
So f prime of x here is 1 over whatever is inside. That's this x or u, x cubed plus 1. It's in parentheses because we're going to multiply by the natural log of 10. That's the base.
Mhm.
And then what's the derivative of the inside function here?
3x squared.
3x squared.
Did we do some of this last week?
We probably did.
I feel like I've seen some stuff like this before.
Should I continue, or do you
Yeah, keep going.
okay.
It's good practice. I need to practice.
Yeah, this one you can rewrite slightly. I mean, you can put 3x squared up top. You'll want to ask your instructor how important that simplification stuff is for him or her. All right, let's move to question 3. You got all that down, and always let me know if you want one like it.
Okay.
You can always do one like that if needed. So number 3 is the sine of the natural log of x. This is a chain rule question. You have your outside and then your inside function here. The derivative of sine is cosine. You always keep the inside function, and then you multiply by the derivative of the inside function.
Which is 1 over x, right?
Exactly, just 1 over x.
Okay.
And if you want, you can rewrite as cosine natural log x over x if you want to make it pretty.
Okay.
Yeah, this is looking a little bit familiar because I can remember myself saying, well, number 5, you have a couple of options here. One is to actually use the property of logarithms. You know, if you have log a over b, this is log a minus log b, and then take the derivative. Or you can take the derivative as is and use chain rule. Which do you think?
I prefer the first option.
Separating it out like this?
Yes.
Okay, so this is I call this a rewrite step. There's no calculus in this step. It's natural log of 1 minus natural log of x. You're just rewriting it. Natural log of 1 is always equal to 0. So you could even rewrite it further. You could say, oh, this is 0, so it's just negative natural log of x. Now we're ready to take a derivative. So the negative just comes with derivative of natural log of x is 1 over x.
All right.
And you're done. Number 7 here. So this is a product rule problem with a tiny little bit of chain rule over here with that one. So can't remember how we do it. I think you said uv prime plus vu prime. It's your preference. This is u and this is v. Yeah, so our derivative is, so we keep the first, sine x. The derivative of natural log of 5x is 1 over 5x times, what's the derivative of 5x?
5.
Just 5 plus, okay, v is ln 5x. Derivative of sine is cosine x. And then you probably want to do some cancellations over here. The 5 and 5 go cancel out. So this is sine x over x plus cosine x natural log 5x. And then we're up to 9. All All right, this one it's definitely one of those good ones to use some rewrite steps, because otherwise you have to do the quotient rule when you take the derivative of the inside function.
Mhm.
So if you break this apart, big A over big B, natural log A minus natural log B, you get something pretty straightforward. The rewrite is natural log A minus X minus natural log A plus X. So now you take your derivative. This was just a rewrite step. G prime of X, the derivative is 1 over whatever's inside, A minus X, times the derivative of the inside function. Now the variable is X, so you treat A like a constant. So it's just -1 because that's the coefficient in front of X. Minus 1 over A plus X, and then the derivative of the inside function is just 1. Is that okay?
Yep.
All right, so then just a little bit of rewrite here. -1. Now this minus could actually go with the bottom stuff down here, where if you apply it to the bottom, you just change the sign, so it becomes 1 over X minus A. X becomes positive, A becomes negative, minus 1 over X plus A. This is probably I'd see it in the textbook solution.
Alrighty.
Okay, so you said to go through 13. Good.
Yes.
If we do, yeah, because these are more difficult, and they're definitely a good use case of when you might actually use logarithmic differentiation.
Okay.
So if you were to just take this derivative as is without doing a rewrite step, you'd have 1 over this inside part, and then you'd have product rule. And that's truly okay. But you can also treat this as natural log A times B, natural log A plus natural log B. So G of X equals natural log X plus natural log square root X squared minus 1. Now this on the right can also be rewritten. So the square root really means, it really implies a 1/2 power.
What happens to the X that's out, like to the left of the
Right there.
Oh, okay. You just move it. Okay.
Yeah, like that's A, and all of that's your B.
Oh, okay. Okay.
Okay.
Oh,
But really this over here, this X squared minus 1 is to the 1/2 power, because that's what the square root means. And there's another property you remember, natural log X to the N equals N natural log X. So that exponent comes out in front. So this 1/2 is going to come out in front. So this thing becomes natural log X plus 1/2 natural log X squared minus 1. Now what you want to be able to do for your exam is be able to get from the original line to this step right there as quickly as you can, because the derivative is much faster here. There's no product rule, very little chain rule. So the derivative of natural log of X is 1 over X. Is that okay?
Yep.
Plus 1/2 times 1 over the inside part, X squared minus 1.
Times the derivative of the inside.
That's right, 2X. So notice that this 2 cancels with that 2. And you get 1 over X plus X over X squared minus 1. That's pretty reasonable. Okay. Now, if you've got all that down, I just want to briefly run through what it would be like if you didn't do that, so you can see the difference between them. So let me grab this again. All right, so the derivative is 1 over X square root X squared minus 1 times now the derivative of this. And this is product rule. This is now U and V. And to be clear, V is really X squared minus 1 to the 1/2 power. So it's X times, now we're going to use power rule, 1/2 X squared minus 1 to the minus 1/2 power times 2X plus square root X squared minus 1 times X. I'm sorry, times 1, because it's the derivative of that first one. Okay. Now, if you had to simplify this, this would be horrible.
Uh-huh.
All of this.
Yeah.
But you don't. So that's where your instructor will likely tell you, use logarithmic differentiation, like thou shall use logarithmic differentiation.
Mhm.
And just to be clear, this line right here is equal to this line up above.
Okay.
It doesn't look like it at first
Yeah.
glance, but it truly does. Okay, number 13. 13. All right, we got g of y equals, now we're going to use a rewrite step here. So again, natural log a over b, natural log a minus natural log b. So this is natural log 2y plus 1 to the 5th minus natural log square root of y squared plus 1. So just breaking it apart, nothing else there. We're going to now use the property natural log x to the n equals n natural log x. We're going to bring this 5 out in front. 5 natural log 2y plus 1 minus, this is really to the 1/2 power over here, the y squared plus 1. So we're going to say 1/2 natural log y squared plus 1. And you do all this to make the derivative easier, because natural log is just 1 over.
Yeah.
So this is 5 times 1 over 2y plus 1, we're at the derivative step, times the derivative of the inside function, which is 2, minus 1/2 1 over y squared plus 1 times 2y. So 5 times 2 is 10, 10 over 2y plus 1, minus this 2 cancels with that 2, so you get y over y squared plus 1.
All right. Makes sense.
Okay, so we just went through 1 through 13. Do you want us to do other examples like these?
No, I just need to practice them now, really.
Okay,
But I want to do number 47. I think I sent it to you.
47 is there for sure. What else? Well, if you don't, we'll get through this, then we'll decide. So
Okay.
let me get this up here.
All right.
This one's just to differentiate and find the domain. You actually should find the domain first, so we'll do that. All right. So there's like a couple of commandments of math. One is not to divide by 0. So we need to figure out where is 1 minus natural log of x minus 1 equal to 0. And this occurs when 1 equals the natural log of x minus 1. So in effect, we're trying to figure out, well, where does this equal 1? To undo ln, you use e to the 1 equals e to the natural log x minus 1. So e equals x minus 1, e undoes ln, x equals e plus 1. So this is the only place where you have problems. So your domain is everything but this, but there's more. What do you remember about the natural log function? You remember what it looks like graphically?
Yes, just the inverse of, yeah.
Yeah, it looks like something like that. So ln is only good for x greater than 0. Okay, so this thing right here, you can't give it a number such that the inside part needs to be greater than 0. So there's a little bit more to this. That's why I guess it's a pretty good question. X minus 1 has to be greater than 0. So x has to be greater than 1. So just to put that in context, like let's say x equaled 0. Natural log of 0 minus 1 does not exist. X negative 2, we have the same problem. That natural log of a negative number just doesn't exist.
Okay.
So we said, well, it can't be e plus 1, but it also has to be greater than 1. So if you looked on a number line, you start at 1 to infinity. Here's e plus 1 somewhere. It's everything but that. It's all these numbers in between and then to the right of it.
Yeah.
And if any of that wasn't clear, I'd be happy to go through it again.
No, I'm good.
Okay, great. All right, so now let's actually go back and do the derivative. This is does it tell us to use logarithmic differentiation? No, it doesn't.
It's just derivative
Just
differentiation.
derivative. Yeah. So what do you see? Like where would you kind of go? What's your
My initial thing is quotient rule.
Yep, it looks like that.
Mixed in with some looks like we're gonna have to use log thing as well, maybe.
Yeah, it's within the bottom, there's a chain rule part. Not great, but that's what it is. So
yeah.
If you don't have this down, you're going to want to have it down by the exam to do that. So it's the bottom. The derivative is the bottom. 1 minus natural log x minus 1 times the derivative of the top, which is 1, minus the top times the derivative of the bottom. So derivative of 1 is 0 minus the derivative of ln is 1 over the inside part times the derivative of the inside part, which is 1, all over the bottom squared. Something like that. Now we probably want to clean this up a little bit.
Mm-hmm.
Do you know how much your instructor emphasized that in class?
To clean it up?
Yeah, like to simplify. I mean, this is done.
He says it just like if you want to.
It
I don't
depends.
ever simplify or like.
Yeah, then I would just tell you to leave it and move on.
Can we go back to the top part steps?
Yes.
Go over it real quick.
Yeah. So the bottom is 1 minus natural log x minus 1. That's right here.
Mm-hmm.
The derivative of the top function is 1.
Okay.
Minus the top function times the derivative of the bottom. So the derivative of the bottom is 0 minus and then ln this. Now, did you happen to see this in class, something like this? Like, what is if y equals x to the x? Did your instructor talk about using a logarithmic differentiation for that?
Yeah, he did. I don't remember it though.
Okay, we should do that now. That's kind of where this leads.
I got one more question about the previous question.
Sure. Sorry, go ahead.
So to write the answer for the domain, what would it be?
Oh, I'm sorry. I did all this work up here and didn't make that clear. The first thing we just figure out that e plus 1 is excluded and that it has to be greater than 1. So it's from the domain is from 1 to e plus 1, comma, e plus 1 to infinity.
Okay. And then I just want to go over how you got that domain again.
Absolutely.
For the left side, when you put an e.
Yeah.
To it.
So let me just do this again. So we have to set the bottom. We have to set the bottom equal to 0. The bottom cannot equal 0 is the truth. So, but you still solve for x. So how do you solve for x? Well, you move this ln over, so you get 1 not equal to natural log x minus 1. And then e to the natural log of x equals x. So that's how you undo the ln. Do you remember that? So it's e to the 1 not equal to e to the ln x minus 1.
Okay, you gotta do it to both sides.
Yes, both sides. Right. So then you add 1 to both sides and you get x cannot equal e plus 1.
Okay.
And you might think you're done there, but if you looked at a number line from minus infinity to infinity, and you said there's e plus 1, you've got all these other values, right?
Right.
But I mentioned before, I said, well, when you go back and look at it, you're like, wait, natural log itself is already restricted.
Uh-huh.
Its domain is x greater than 0. So you can't just say, oh, it's everything but e plus 1, because like 0 is right there. Okay.
Uh-huh.
And so that doesn't work. So we have to look at that part. We have to say, oh, where is the natural log of x minus 1? Where is that okay? And that's where you set the inside part greater than 0. So you set x minus 1 greater than 0, x greater than 1.
Okay.
And that's where you're like, oh, well, there's 1. So it's everything to the right of that.
Mm-hmm. Alrighty.
So that's where you say, oh, it's everything to the right of this.
Okay. Well, okay, I see what I want to do. Or I see two that I want to do.
Okay.
I want to do 55 and 57.
All right. Yeah, these are classic questions. So when you look at this, you're supposed to see that you have no way to do this, because the only ones you know about are x to the n and a to the x.
Mm-hmm.
This is power rule, and this is an exponential function. Like, we don't have a word for this. It's a variable to a variable. So the only thing you can do, and this is, I call these I call them a non-obvious thing to do, because that's exactly what it is. Until you've seen this, you would have no idea what to do. So you're supposed to take the natural log of both sides of the equation. So that's the first step here.
Okay.
Now, from your logarithmic properties on the right here, you can bring this x out here. X natural log of x. That's using your logarithmic properties.
Okay.
Is that okay?
Yes, sir.
All right. Now, when you take the derivative, there's so much here. When you take the derivative of the left side, it's 1 over y. And then we did some implicit derivatives.
Yep.
It's dy dx or y prime times y prime, because that's the derivative of the inside function.
Okay. Yep.
Is that okay for the left side?
Yes, sir.
All right. Now this is the product rule. So we got to do product rule derivative here. See if you can do that on your own, please.
Okay.
That's the UV stuff.
Grab my paper. Alrighty. It's I got x times 1 over x
Plus natural log of x times
1.
1.
Yeah.
Right. So this becomes, when you simplify it, 1 plus natural log of x, and the left side is y prime over y. Is that okay so far?
Yes, sir.
Okay. Now you're trying to get y prime. So you multiply both sides by y. So from the previous line, you multiply both sides by y. So on the left side, it cancels. And y is your original function.
Mm-hmm.
So you substitute that and you take this and you put it in for y. So your y prime is 1 plus natural log of x, x to the x. Because you replace y with this x to the x.
And that's the answer.
That's the answer.
Okay. Yeah, I did that in class. I just didn't remember.
It's weird. You
It
gotta
makes
like
sense, though. I understand it.
You'll get a problem like that on the exam. And if you haven't done it before, some students in your class may not be working as hard as you, where they're trying to work through these problems. You get on the exam, like a 57, like we're about to do, and they're like, I have no idea.
Yep.
And you have to know to take this initial step of taking the natural log of both sides of the equation. You might have done this when you were doing some limiting stuff, or it might be upcoming with L'Hopital's rule.
Yeah, we're doing that right now.
Yeah, so it's going to come up again. So you take the natural log of the left side, and you take the natural log of the right side.
Whenever you get a variable that's to the power of another variable, you do what you're doing right now. You
Yes, or a function to a variable. Yes.
So whenever a variable is in the power slot.
Well, you got to be careful here. Like if I asked you for, if I say it's 2 to the x, the derivative of this is I mean, you actually could do exactly what we did, but you would be marked wrong because this one has a known derivative.
Yeah.
But yes, in general, yes, like 80% of the time, sure.
Okay. All righty.
Okay, so on the right-hand side, this becomes x natural log of cosine x. On the left-hand side, it's natural log of y. So on the left side, when you take the derivative, it's 1 over y times y prime or dy dx. The right side is almost always product rule. So we got to be able to do this. Now this product rule requires a chain rule part. So it's x times 1 over cosine x times the root of cosine is minus sine x plus natural log cosine x times 1. Is that okay? Is that clear? All right. Now on the right hand side, like this is where it's like you want to say, okay, sine over cosine, I can deal with that. That's tangent. I can make that change. So it's negative x tangent x plus natural log cosine x. And on the left here, it's y prime over y. Now in all of these problems, just like I said, it's almost always a product rule. It's almost always that you multiply both sides by y.
Mm-hmm.
So you clear the y on both sides of the equation by multiplying by y. And that's your last step here.
And then you just substitute the y for the original function.
Yeah.
All right.
So you get y prime equals minus x tangent x plus natural log cosine x times the original. And the original was y was cosine x to the power of x.
All right.
And you're done.
All righty. I want to move to 3.5 problems.
Okay. Let's see here. I only see 3.3. The other cam scanner thing that I got here was like it looks like a chemistry thing, but if you need help with, I can help with. But I only see the questions for 3.3.
Oh, wait, chemistry thing. Did I attach the wrong thing? Or
Yeah, no big deal. I mean, if you can send it over,
yeah, I can just send you the picture over text right now.
That's fine. You can also chat, whatever's easy. Yeah, we could just get that over.
I couldn't attach. I took two separate
oh, that's right. Yeah, we can't.
things, and I tried to zip it so they'd be together. So maybe I don't know. I guess I messed up.
All right. Let's see 3.5 here. Okay. All right, I got all these up. So let me pull something up here to send back to you that you're going to want to get down. It's a Trig cheat sheet. I'll send this to you in the chat, and then I'll snip it in as well. You're going to want to know your unit circle, and you probably remember that from previous classes.
Yeah, I'm not too like I don't have it memorized. I need to get it
Yeah, it's
memorized.
like your derivatives. You got to know it, or you just have no chance here. There's videos on it. I probably need to put one up that shows you how to memorize it, but you just have to get it down.
Yeah.
And there's no shortcut here for learning it. So here's your unit circle. All the problems you sent me, we're going to do based on knowing the unit circle.
Uh-huh.
I can also show you some shortcuts here for this, but you want to do one A, B, what do you want to do? Which ones for this?
He assigned 1, 3, 5, and 7.
1 through 5 and 7. Okay, so let's look at 1A, which is the sine inverse or arc sine of square root 3 over 2. So what this is really asking, it's saying, let me see if I can type this here. For what angle is the sine of that angle equal to, in this case, square root 3 over 2? Now the y value is sine.
Oh, would the answer be pi over 6?
So there's actually two answers. There's pi over 6, comma. No, I'm sorry. No. Pi over 3.
Oh, okay.
What you're talking about? It's pi over
No,
3.
sorry.
Sine is the y value. So there, and
Oh, you're right.
2 pi over 3. Okay. Now you're like, well, is that it, Matthew? Like, no, there's actually more. So arc sine is only defined, and this is on page 4 of that reference sheet. It's only defined, and this gets more confusing, from minus pi over 2 to pi over 2. So which of these angles falls in there? Well, pi over 3 does, because 2 pi over 3 is over here. So that one is no good. And this is your answer.
I'm not sure I understand that part you just explained.
Yeah. So there's a sequencing of doing this. So let's try another one. We can do a lot of these, so it's not too bad here. Let me just move this down. I guess we can copy it each time. All right. Okay, let's look at another one here. Another one is 1B. Let me do 3B next, because it's another sine. So we'll try to, because that'll make most sense here. Sine inverse 1 over square root of 2. It's the same question. It's for what angle is the sine of that angle 1 over square root of 2? Y is the sine value. And you're going to say, well, there's nowhere that it's that. You're going to look at all the y values and realize, oh, there is none. Because 1 over the square root of 2, you have to rationalize. You have to put square root of 2, square root of 2. So it's square root of 2 over 2.
Okay.
And then these are equivalent. The sine, arc sine of square root of 2 over 2. So again, for which angle is the sine of that angle square root of 2 over 2? So there and there, pi over 4 and 3 pi over 4.
So how do you know which quadrants to stop at? Because in quadrant 3, it's there, and quadrant 4, it's there too.
But it's a negative.
Okay.
And it's negative.
Oh, okay.
So
okay.
So there's two answers. Yeah, there's two answers, but only one of them works for the inverse. Okay. And the one it works for is, if you look at where arc sine is defined, it's only defined from minus pi over 2 to pi over 2. So pi over 4 is here. 3 pi over 4 is there. So it can't be that one. So it must be that one.
Okay.
But there's like 3 or 4 things that go into this, and it's very confusing until you've done this, many times.
So if it was if the y value was a negative, you would go to quadrants 3 and 4 and do
Yeah,
exactly what
I
you
mean,
said.
let's do it. Let's say I wanted the sine inverse of -1/2. So where is the y value -1/2?
It's right there.
7 pi over 6 and 11 pi over 6.
Uh-huh.
Okay, but you have the same problem here, and it's actually worse this time because it's only defined from minus pi over 2 to pi over 2. And 7 pi over 6 is over here, and 11 pi over 6 is over here, but 11 pi over 6 is not between minus pi over 2 and pi over 2. So you actually have to subtract 2 pi from this.
Wait, why isn't it?
Well, because it's like asking like what numbers are between 1/2, -1/2 and 1/2, and your number is 11 over 6. So there's your number line. 11 over 6 is over here.
Okay.
And it just doesn't fall in between. So the idea, this is the idea. 11 pi over 6 is this angle. That's 11 pi over 6, but it's also minus pi over 6. If anything, if everything I'm saying is not making, it's just not clear at all, this all comes from Trig, and maybe we need to just dive into that briefly to refresh.
It's just me not completely understanding the unit circle.
Okay. I assume you have access to YouTube. You can go and find some unit circle videos, or we can do it right now and do as much as you need to get through this.
I'll do it on YouTube.
Okay.
But for now, I just want to learn how to solve these problems.
Yeah. And so the next one, let's see here. So we'll do 1b, which is cosine. And yeah, okay. All right, so 1b is cosine inverse of -1. So again, you're looking at your unit circle. Do you have your unit circle? Or do you want me to grab that one, snip it in here again?
I can pull it up.
Okay. Where is the x value? Because cosine is the x value. Where is the x value -1?
It's on the axis of it on the left side.
Right over there. So the angle is pi. So the answer is pi. Okay. Now cosine inverse is nice. It's defined from 0 to pi. So this is good. So you're doing two things. You're like figuring out, well, what could it possibly be? And then which ones is it okay with? And so the answer is pi.
Okay.
But if it was like the cosine inverse of -1/2, you would get two angles and only one of them would fit in this window.
Right.
Okay. So we did 3b, we'll do 3a next. This is arctangent. Arctangent is the same as tan inverse of 1. So there's a few ratios of this. This is where the sine over the cosine values equal 1. So that means it's wherever they're the same, and that's the square root of 2 over 2 over the square root of 2 over 2. Basically on the unit circle, it's wherever x equals y, which occurs right here at that angle, pi over 4, you'll see. And if you go all the way around at 5 pi over 4. Do you see those where x and y have the same values in the unit circle there? So there's two possibilities. It's either this one or this one. Well, again, arctangent, like arc sine, is only defined from minus pi over 2 to pi over 2. So which one is it? Well, it must be this one. It must be the pi over 4.
Okay.
because the 5 pi over 4 is over here and it's not in this window.
This might be a dumb question, but if arc sine and arctangent are that half circle, what is regular tangent and regular sine?
They're good everywhere. It's just these
Okay.
inverses. These
Okay.
inverses are
Okay.
restricted.
All right,
And
that's
it,
my
and it comes from when you graph an inverse that you would see that it doesn't pass the horizontal line test except in these windows. Ranges of numbers, minus pi over 2 to pi over 2.
okay.
Most people don't understand this until they've been through it many times. So
Yeah.
you're doing your best here. We got 7, 5 to go through, but it's totally understandable if this isn't clear yet.
Okay.
It truly is. Okay. Sorry about the loud bang. Okay, 5a. You have the tangent of the arc tangent of 10, which is tangent of tangent inverse of 10. So there's properties, and this is one of them. I'm going to just snip this in. I don't know how many of these you need to know, and then we can maybe talk about how to do it by hand. We need to. This is a straight property, and it has to be exactly this order. If it's not this order, it doesn't work. Like the tan inverse of the tan of x is not necessarily x, but this one is 10.
Okay.
And you'll see that in the next one. It's not the property. So 5b, sine inverse of sine of 7 pi over 3. So I'll snip in the property and you'll see, oh, it's not the same. So this is the property, but it doesn't apply to this problem. So you have to start here. What is the sine?
It doesn't apply. Why is it? Oh wait. Okay.
Yeah, the order is slightly different.
Yeah.
And if you get this on the test, it'd be very common to not pay attention to that small little difference and then
Yeah.
Right. So on your unit circle, where is 7 pi over 3? Well, it's going, you go all the way around. That's 2 pi or 6 pi over 3. And then one more pi over 3 gets you to 7 pi over 3. So that gets you right there.
Okay.
What's the y value there at sine 7 pi over 3?
Square root of 3 over 2.
Yes. Sorry, I'm thinking of something else. So this is the sine inverse of the square root of 3 over 2.
Mm-hmm.
So now again, it's like one of those early problems. Like for what angle is the sine of that angle square root of 3 over 2?
Okay, I understand.
And it's two places. You're going to find, oh, well, it's here and here. So pi over 3 and 2 pi over 3. So you might think both of those are correct, but sine inverse is only defined from minus pi over 2 to pi over 2.
So it'd just be pi over 3? It'd
be just be pi over 3.
Okay.
And then you might say, well, say, Matthew, like you just said, this doesn't work. Well, you're right, it doesn't work because 7 pi over 3 is not pi over 3. But more, it's not because it's the coterminal angle. It's because it just worked out in the first quadrant.
Okay.
So try not to make like a jump to conclusion like that.
All right. Makes more sense. I just gotta learn the unit circle.
Yes. All right, what else do we got? Anything else on this page?
On that page. That one, no, but I guess numbers. Oh, wait. I gotta send you another freaking picture here. Or 17, we're not gonna get through all of them, but 17, 19, 21 were assigned. And 25.
17, we'll start with 17. You can give me more if we have time. All right, so 17 is y equals tan inverse x squared. This is a power rule followed by a chain rule. What is the power rule? Do you see that it's this 2 here?
Yes.
So it's 2, keep the inside function, tan inverse of x, power of 1. And then you need to know the derivative of arctangent. That's one of those you just have to memorize. If you don't know it, you got to look it up.
Yep.
And you just have to have it down. So flashcards, units, or whatever you're going to do to learn these things, there's a lot you're going to get. You have to know that. Okay.
We have it written down. I just gotta memorize it.
You said 19.
Yep.
All right. So y equals sine inverse of 2x plus 1. So this is a I call it like a function followed by a chain rule. So you need to know the derivative of arc sine. So do you have your derivative table up for that?
I do not.
All right. It's 1 over the square root of 1 minus x squared. So let me just write it over here, but because it kind of applies, kind of doesn't. It's 1 over the square root of 1 minus x squared, but that's if it's an x here. So if it's not an x, whatever x is goes in that position. So here the 2x plus 1 is going to go in that position. So your y prime is 1 over square root 1 minus, and instead of x, it's 2x plus 1 squared. That's the first part. Times the derivative of the inside function.
Okay.
What is the derivative of the inside function?
2.
Just 2. But you got to know this one.
I have it written down right here.
Great. Great. What was the next one?
I think it was 21.
21. 21's a power rule or product rule here. So we got g of x equals square root 1 minus x squared arc cosine. But I'm going to write this like cosine inverse of x. So this is a product rule. So g prime of x, it's square root 1 minus x squared times the derivative of cosine inverse. This is negative square root 1 minus x squared, okay, plus you keep that one, cosine inverse of x, and then the derivative of this, it's really 1 minus x squared to the 1/2 power. So it's 1/2 1 minus x squared to the minus 1/2 times the derivative of the inside function, which is minus 2x.
Alrighty.
And then I just say briefly here, a lot of things cancel. That cancels with that. So you get -1. This 1/2 cancels with that. And this goes on the bottom. So you end up getting minus x cosine inverse x over the square root of 1 minus x squared when you simplify.
Okay.
All right. We will have to end here. Trenton, thanks so much for scheduling. I'll send you the notes and the screen recording out.
Alrighty.
And I'll see you next time.
All right. Thank you.
Have a great night. Bye now.
You too.